Hey guys, today we're going to be doing some reverse engineering, and in a slight change of the way I normally do things, I am not actually working on it yet. I'm just getting started and I'm getting my parts together. So first things first, here is our target. Oh wait. Hang on. That's not the target. This is our target. This is the OBD-C adapter that Kama created to restore support for the Chevy Volt and all the pre-existing GM cars that lost support when the Black Panda and the Kama 2 came out. It essentially functions. It makes the Black Panda operate like a gray Panda by adding back some of the things that were taken away. Well, one of the things, the low-speed single-wire GM LAN. Now, in order for me to make a feature-complete camera harness, I need that gateway. I was not able to get the schematic from them. I asked nicely and got ghosted, but that's how they roll. So, they don't seem to have a big problem with people reverse engineering their stuff. So that's what we're going to have to do. And considering the schematic I build is going into something that will be submitted to them, I don't really think it's going to be that big a deal. I've already pulled off the actual USB-C connector, so and I've identified all the chips. Check this out. So, here, let's talk about what's on there. On the top, up here, that is a low-speed single-wire CAN transceiver. It's a special one that has that doesn't require inductors, which is special because normally, when I was looking into building something using a microcontroller, the single-wire CAN controllers all require this voltage matching and inductors and stuff. They found one that has it all built in, so that's pretty sweet. The next one down is this must be the magic. It is a quad 2-input NAND gate, auto style, whatever. I've got to even look into NAND gates and how it's wired up. Moving on, we're going to skip this one. It's just a voltage regulator. Then we have a high-speed CAN. Oh, cat transceiver. There's no cats around to look at. High-speed CAN transceiver. This high-speed CAN transceiver goes through this NAND quad input NAND gate and is then connected directly to the low speed CAN transceiver. I don't know how that's possible. Mind boggling to me, but I've heard NAND gates, they can function as a buffer of sorts. Think about flash memory. It's NAND flash. Now, the word means the same thing. They use the same gate, but it's a latching gate in memory modules. Nevertheless, my guess is this is being used as a buffer of some kind. And the output on these is designed to connect to a microcontroller with a CAN controller on it. The fact that we're connecting the butt end of two CAN controllers that are meant to be connected to a microcontroller without a microcontroller and it works is profound in my mind. We're gonna get it figured out how it's all wired up. I have a box full of, you see, these are you can't see because it's not focused. The things I haven't identified yet are all these resistors and capacitors on here, all the accessory little components. To get their accurate values, I've got to pull them off. That's not going to be fun, but I do have the necessary tools to do it. So what I think I'm going to do first is the part I've not been looking forward to, and that is tracing the circuit. I feel like there's got to be a good way to do this. I have created this monstrosity where I was going to attempt to start tracing using colored pens. It wasn't going well. Well, this is just fabulous. I was going to run Adobe Premiere Rush. I have an intro video about the Suburban. It's long, but it has a lot of driving examples and kind of covers the whole background. That I used Adobe Rush on my phone, and 20 minutes in, the video hangs, and so the last 20 minutes is just a still frame. So I installed Adobe Premiere Rush on this, my backup laptop. Doesn't have a dedicated GPU, has an i5, 8 gigs of RAM, and Adobe Rush crashed after I loaded the video segments in. So this laptop is not going to work for video editing, even in a pinch, apparently. But it seems to run Easy EDA okay. So one of the possibilities I'm considering is taking all these components and the little bitty components and throw them in a schematic on here, and then as I discover what connects to what, just update the schematic, and then maybe that would save me some time. That's what I'm going to try, I think. So, I guess stay tuned for part 2, where I have either made progress or tried to come up with a new way. Thanks for watching.